if any of you guys who are here have missed any classes and want to make sure that you get points for attendance, why don't you volunteer to help us review what we talked about last class? Is anybody in that position? And tell me your name too when you do it so I can mark you down. Yeah, that's worth reviewing, sure. Black bodies, atomic bombs, Nobel Prizes, those things were all kind of swept together. So this microwave signal was discovered, right? And the microwave signal turned out to have a black body spectrum to it. It was a very low energy signal. It's in the microwave region, which is about as red as it gets, if you can imagine. It's not actually visible stuff. And so this signal, in some sense, the hiss of the Big Bang had been predicted for a long time. Actually, what I learned yesterday, I had a really interesting conversation with this professor in Brazil named Andre Assis, a really, really interesting dude who spent a lot of time translating manuscripts from classic physics into, let's say, common languages like English and Portuguese. A lot of these were written in German and French. Anyways, he pointed out to me that actually people had, before this Big Bang idea was a thing, that several authors predicted that there should be a faint glow, a background radiation due to, let's say, all of the stars in the sky. There should be some amount of radiation that's just constantly bouncing around the room, so to speak. And they actually predicted the temperature of that. They thought it would be a black body spectrum, and they predicted the temperature of it to be around 5 Kelvin, which isn't too far off from the CMB. Now, what's really interesting about that model is that, well, if the stars, everybody knows the stars are black bodies, so it makes sense that if you're going to predict some hiss in the background that's due to the stars, it should also be a black body. Now, when Penzias and Wilson discovered this hiss, this microwave background, which they became famous for, won the Nobel Prize, and attributed it to the birth of the universe, I don't think anybody expected that to be a black body, right? Because, of course, this whole story that black bodies can be produced by gases, right? Just like that moment at the supposed beginning of the universe was the formation of the first atoms. And when the first atoms formed, they're, of course, gaseous, right? They were really hot and moving around really fast, so they're called a gaseous plasma. They have some electrical charge associated with them and so forth. Separation of charge, I guess, is how it would be put. But I don't think anyone expected that would be a black body because, well, gases don't do that. I think that the only reason they got away with saying that it was possible is, of course, because if you ask an astrophysicist whether a gas can make a black body spectrum, they'll say, yes, because the stars do it. And they believe that the stars are gaseous plasma. But that's the only example in the universe they can point to. They'll never be able to do that in a laboratory and make a black body spectrum from a gas. So it's a bit of a circular argument. So Nobel Prizes, black body, cosmic microwave background radiation. And then what I was trying to say about the nuclear explosions was that if you're looking, this theory was put forth by my friend Pierre that perhaps this microwave background signal emanated actually from the black body spectrum of the hydrogen bonding lattice in the oceans themselves. And an interesting sort of corollary to that is that when these nuclear bomb tests were going off, they shock compressed the water. Now, if you compress a substance, you change its lattice arrangements. That is, like, you can think of a lattice as a crystal arrangement, so how the molecules sit with respect to each other. If you compress them, you change the lattice. When you change the lattice, you change its optical properties. And you can see this in the nuclear bomb tests because water, which is generally transparent in optical frequencies, right? You can see through water, right? If it's clear, you can see to the bottom of a glass of water. But if it's compressed, it becomes optically black. So its optical properties change just because the lattice is compressed all of a sudden. And so what I'm trying to say with that anecdote is that that is an argument that water indeed does have a lattice to it. It might be a transient lattice. It's not fixed like in this table, right? That there's a hydrogen bonding network that is, in some sense, the water molecules swap in and out of it, but it still has some sort of cohesive layered structure to it. And we know that's the case because if you compress water, you absolutely change its optical properties. And so the argument is that, hey, water is extremely absorbent in the microwave, right? That which absorbs must emit, and so it must be emitting in the microwaves as well. Pierre's done a great job of going through and showing the mathematical plausibility of the energetics associated with that and how it would actually end up giving a 3K signal. So I don't know. I don't know if this microwave signal is from the oceans or if, like the 19th century physicists thought that it would be from the background hum of all of the stars collectively, sort of bouncing their light around the room. One thing I personally feel pretty convinced of is that it's not due to some gas, right? Because that doesn't make any sense with all of the laboratory research that we've done on gases. They don't give black body spectra, which means that it's probably not from gas at the beginning of the universe too, as far as I can tell. So I'd probably get thrown out of the room if I was at an actual astrophysics university giving this lecture right now for that. But that's how I see it, and you're welcome to make up your own minds. But those are the facts, as far as I can see them. All right, what else did we talk about? Yeah, that was another interesting point of the puzzle too, which so there's a couple of things part of that. So you mentioned the communication satellites calibrating their signals, or I think they're calibrating their orientation. They align themselves to the strongest peak of the cosmic microwave background signal. And what's really bizarre about that, and Pierre actually discovered this too, he was going back through these white papers of these different comms companies, is that you would think that if it was actually cosmic in origin, that the most bright part of it would probably be pointed towards the cosmos, right? But for some reason, all of these satellite companies were finding that the brightest emission point was essentially perpendicular to the ocean, right? And Pierre started looking at the let's say the hydrogen bonding frequency emission, the temperature, let's say that the water gives off as you point your antenna at different angles. And what he found was that when you point the antenna directly at the water, you get a pretty reasonably close to true temperature. It's not totally true because I think it gives you something in the 180 Kelvin range, and the oceans are obviously around 300. That's because, remember, a black body has to be perfectly insulated from the environment. There can't be any conduction or convection that's sopping some of the heat away. If you lose some of that heat, then it's not going to be radiating away all of its heat. So you only are going to see what's being radiated away. But anyways, if you point an antenna directly at the ocean from above, you get a pretty high temperature in the upper hundreds, right? But as you turn that antenna away from the nadir, away from the point below you, the funny thing happens is that the temperature of that signal falls, and it falls precipitously until when you're actually pointed at the limb of the Earth, you get something like a 3 Kelvin signal, actually. So pretty interesting that would be the peak signal for the CMB off at the limb of the Earth. So all these things conspire to support his idea that perhaps the oceans are actually involved in this. The other factor in that that's really compelling is that the signal that you get here on Earth is nicer than the signal that you get away from Earth, right? Like the error bars on that signal, that curve, that blackbody curve, they don't get better the further you get away from Earth. They get worse, actually. And that's pretty strange, too. So I don't know if it's true. I just know that it's not coming from a gas. That's all I know, for sure. And it makes a lot of sense that it might be coming from the oceans, too. But it's going to be a mess to get past that if it happens. Like I said, Nobel Prizes have been given for this stuff. I don't know that any Nobel Prize has ever been taken back. I don't know that any discovery Nobel Prizes have only been given since I think the 1930s, 20s. I don't know that anyone's ever walked back on one yet, but come on, it's got to happen people have to be wrong sometimes, not necessarily about this, but about something, right? It's inconceivable that people wouldn't change their minds about how things work in nature the more that we understand, right? And I don't know, I think it's really important as a society, like as humans, right? That we learn, both in our personal lives, but also publicly facing, like how to just be okay with being wrong sometimes. Like, what does that look like? You can't have so much pride that you can never consider that you were wrong, right? Sometimes you step on someone's foot you didn't mean to, right? Sometimes you interpret an experiment incorrectly and everybody bought it for 50 years. But there's got to be a way back without, it being so shameful, right? It's got to be okay. And so I think that we're going to learn that lesson the hard way or the easy way. It's kind of up to us. And it seems like we're going down the hard way right now. And Pierre's, he's a brilliant man. He's been studying this stuff for the last 20 years. He was the director of the radiology department at Ohio State for, I think, 25 years. He was like one of the most sought after scientists when he came out of his postdoc. He basically made the MRI machine what it is today. Before he worked on the MRI machine, it was just these grainy, pixelated images. And in the course of a few years, I think, I don't want to say orders of magnitude more resolution on it. You could actually see blood vessels in the brain and incredible stuff. And the funny thing is that if you think about what an MRI machine is doing, right? So Pierre's always been attacked for, hey, you're not an astrophysicist, you have no business commenting on this stuff. And he's like, look, what we're doing with MRI technology is the exact same thing the astronomers are doing with radio telescopes. It's no different. We look at light coming off of these cells, and we interpret the spectra. And so it's a preposterous argument that you should have to be someone who just only studies light in the sky, right? People who study light are people who study light. They know what they're talking about. So. Yeah. It's actually one of the interesting tragedies right now. I'm not going to frame it that way. We're at an interesting intersection in the world right now where scientists and doctors and everyone, they have to specialize to this extraordinary degree that's never been the case before. I don't know if you guys have noticed, but as we've gone through this course and we've talked about all of these different scientists in the past, they're all doing like everything, like Robert Hooke's like doing the first drawings of cells under a microscope, but he's also coming up with the basic laws of elastic mechanics for the first time. And he's thinking about gravity. He basically feeds Newton the inverse square law. Like all these guys are just everywhere. They're studying everything. And it's never been less of that than it is today. People study one tiny thing and they just keep getting tinier and tinier and tinier. And these people aren't talking to each other. I may as well share this experience. So I was at this physics conference last week. And I was sitting there with a friend, actually, who's he's a biochemist by training. And we're sitting in this session about the physics of water interactions, let's say. And, talk after talk, these physicists are standing up and they're like, we've discovered this incredible phenomenon here. And the guy, my friend who's sitting next to me, he's like, no man, like we have another name for this in chemistry. Like we've known about this for forever, basically. We just have different language that we use to talk about this hydration phenomena. And so it's kind of like that today, where people are really cut off from one another. They use different languages in different fields, and it's never been more important to articulate all of these things together so that people can actually work on these solutions. I don't think it's a coincidence that my friend Pierre was not in astrophysics when he started actually asking these questions about the CMB and about the nature of the sun. I don't think that somebody who came up through astrophysics would be in the position to ask those questions because they would have inherited this knowledge base that would have precluded them even asking these questions. He's more a guy who's just used to looking at regular bodies, right, like human bodies, but he's still using the same principles, the same Kirchhoff's law for black body emission, all the same stuff, all the same spectral analysis. And all of a sudden, somebody tells him that the sun is a gaseous plasma, and he's like, wait, that's not possible, right? And it's like, it's something that I don't think would ever occur to somebody who came up learning the way that it was and so forth, and the various Eddington theories of radiative transfer, and just kind of being raised in that culture. Yeah.
Just like the window in a shop.
Oh, yeah. Oh, what was that? Maybe that was an experience I had, actually. I don't remember, yeah. But yeah, you do notice that. That's really interesting. So you can, if you see the sunlight, you'll see it split like a rainbow, right? And you can also see the same prismatic effect split if you have one of these lamps. Hopefully you don't. I like the incandescent lamps myself, but if you have some of these maybe in your dorm room or something and you see them split through the window, they'll be split into 3 colors, right? And so you might think, the sun's probably more like that incandescent than it is like that. And then you have to start asking questions. But this is like, it's such basic, it's not even a technical enough argument to really even make its way into astrophysics the way that it's specialized at the moment. So anyways, I think it's really, really exciting, but I think that it's also going to be an incredible passion play of humility and, pride, ultimately, how this plays out. I hope you guys will all think of this class, 20 years from now when this is absolute smashing headlines or whatever, because I can almost guarantee you that it will happen. I just don't know when. But it's going to be incredible. So I'm really looking forward to that. And why is it incredible? Because if the material basis of the stars is not what we thought it was, then pretty much everything that you've read in your textbook is going to be different, which means we have another at least 100 years of work to do to make a better textbook out of it. Right? The story that's told in your textbook of white dwarfs doesn't make sense anymore. These black holes certainly don't make sense. A lot of these things will have to be replaced by new ideas. And so, every once in a while you'll see a headline like, have we reached the end of science? Like, have we figured everything out already? There's a guy we had on the podcast who actually wrote a book called The End of Science. Turns out he was like a little bit of a joker. He wasn't totally serious about it. But it's a reasonable question because the rate of progress has kind of ground to a halt, actually, right? So you see like the iPhone 680 coming out every year, but it's not really different than my iPhone 3 or whatever, right? And so all of this seems to be happening in science, right? And I don't think it's because we've figured out everything. I think it's because we get really comfortable with paradigms, right? Like the gaseous sun. We get really comfortable. They allow us to do a certain amount of progress. And then they have to just break, like shatter into a million pieces in order for us to make that next jump in our ability to sort of work in and with the universe. Yeah. Yeah, it's very safe. I mean, it's hard because you're talking about like a civilization or a cultural, societal level thing. Like, what does it mean for a society to admit it's wrong? Is that even possible? Like, right? These are individuals who are all pieces of this huge machine, right? And they all sort of got each other's backs, and they've all inherited the same basis of knowledge, right? So, it's not that astrophysicists aren't aware that they've never seen a black body spectrum from a gas in a laboratory. They know that. But they've made this incredibly complicated mathematical story of how stars are special, and because they're so big and amazing and magical, something that we've never seen happen on Earth happens in stars, which is that the photons bounce around inside of them for millions of years, and they just happen to come out at the surface at the perfect frequency power spectrum of a black body. And it's the only place in the universe that happens. And it's an impossible thing to argue against, because if you say, well, why can't I see that on Earth? They'll say, well, because you don't have enough gas. And it's like, well, where do you have enough gas? In a star. So it's like a circular argument, right? You can't fight with that. And the guy who came up with that model was Arthur Eddington. And Arthur Eddington, super famous. It's hard to even impress upon you guys how famous and let's say stately and socially important he was, right? He was the guy who brought Einstein to the world, right? He translated Einstein's papers. He was basically like Carl Sagan, Neil deGrasse Tyson, and I don't know who's famous with you guys these days. I don't know what you guys listen to. Like Joe Rogan, maybe? I don't know. He's all these people wrapped into one, right? He's this super huge social guy. And he proposes also to absolutely seal the deal. He's the first guy who proposes fusion in the sun as a means of powering the sun. So he can say whatever he wants, right? So he proposes this idea of how the black body spectrum is generated by this relay mechanism, and people are like, sure, this guy's a genius, let's go with it. And that's where we've been ever since. So, is it because we can't admit that we're wrong? I don't know. I don't know that any individual inside of the domain of astrophysics is capable of admitting that they're wrong. You could say, hey guys, I think we're wrong. They'd be like, there's the door.
Right.
Like, honestly, like, what are you going to do, right? You're going to write a grant, like, are you going to ask for a grant from higher up astrophysicists to help you prove that all of their work is wrong? That's completely impossible. Like, the only way these things change is from the outside, right? Charles Darwin wasn't an academic biologist. He didn't go to university for biology. He didn't have a biology degree, right? Copernicus didn't have a degree in physics when he rewrote the paradigm of the solar system, right? These are like weirdos on the outside who are just like, I think what you guys are talking about doesn't make sense. And they spend their whole lives figuring out all the details of that, and they usually write it in a manuscript that they publish when they're about to die. Because they're like, I don't want to deal with you guys like pillaring me, basically. That's how it goes. That's just how like these huge paradigm shifts have to happen, I think, unfortunately. It's very painful. I know it's been really painful for my friend Pierre, who's had this incredibly illustrious academic career and then essentially had to leave the university because it just wasn't he couldn't study this there, right? I just think that's how it goes, you know? And it's gonna be sad because he's kind of probably towards the end of his life now. I don't think he'll ever get to see any of the glory of it, right? Like I said, I think people will realize that the stars are not actually gas at some point. I think that'll happen in my lifetime probably, next 20, 30, 40 years. Could happen tomorrow, but I don't know that he'll ever get to see it happen. And I don't think Copernicus got to ever really see it happen, and I don't think Darwin ever got to see it happen, right? So these people that we hold on high as like these champions of science, like they didn't know they were champions. They just knew that they saw things a little bit differently than everybody else. So that's kind of how it goes. Anybody else got any thoughts? Yeah. Yeah, that's the central question for paradigm shifts in general. I think it tends to not be that painful. Like, so the Big Bang wasn't a popular idea until the 1960s, and people were still, let's say, pretty divided on it until the 1980s. And it became really popular in like the 1980s, like the end of the 1980s when I was like first coming conscious, like let's say, I was like a small child. So it was like a big deal then. I think people just transition to working on whatever's popular, to be honest with you, for the most part. I think there's huge cosmological questions that you can divert your attention to. You know, the Big Bang proposal has gotten sketchier and sketchier, especially with this new generation of telescopes. They see these fully formed galaxies essentially way too early, right? The Big Bang theory predicted that everything should just be a bunch of primordial stuff still, and they got fully formed galaxies. Now, they're going to build a bigger and better telescope in the next 10, 20 years, right? They're going to have another version of this. What's going to happen when they see fully formed telescopes before the Big Bang, right? I mean, there's going to be a few people who just like linger around and are like, well, we can just, you know, maybe we just had this, you know, we need to move this decimal point over here. We messed up this equation. I guess it just happened earlier, right? So I think these things are going to happen slow enough that people divert their attention to other questions like the galactic rotation thing. What's up with all of this missing material, this dark matter stuff? What's going on? I think there's enough topics that people will have time to adjust to it. And so that's another interesting way that paradigm shifts can happen very quietly too. There's been some of those actually in my lifetime. So when I was a kid, they used to call oil fossil fuels, right? I don't know. You guys hear this still? Fossil fuels? Well, they stopped doing that because they discovered that oil is actually produced oftentimes through completely abiotic processes. The reason they realized that primarily was because they went out to they sent these unmanned spacecraft out by these distant moons in our solar system and found tons of this stuff. Methane, ammonia, all of these like fossil fuels, right? And so it's not like anybody got up on a podium and was like, oh, sorry, we were wrong about that, right? It just slowly stops becoming the way people talk about it, right? So there's a lot of these little paradigm shifts that you see, and they're quiet too. So I think there is a way to do it while saving face. In some sense, I wish that they highlighted that more in these intro biology science classes. where we actually talk about, hey, we do have to change our minds, and that's really beautiful and important and critical to a healthy information ecosystem. Anytime you see people trying to like strangle information, I'm just really sketched out, because that has never gone well in the past, right? So yeah, I don't know. Did that answer your question? All right. Let's. Any last points? I want to make sure that we have time to wrap down. I really want to put a bow on this whole discussion we've been having. So one last thing I want to say for business. Look, if you please consider doing the evaluations for this course. In particular, if you really enjoyed the class, please say so. If you really hated the class, you can say that too, but don't say you hated it because it's a lecture class, and don't say you hated it because it's at 8:30 in the morning. Those are like the two most common complaints I get, and I'm just like, this is not helpful. It's going to continue to be a lecture class. It's going to continue to be at 8:30 in the morning. So if you have ideas about how we could make the assignments more, let's say, integrated or better, anything that's actually going to help me make the course better, that would be much appreciated. So do that. Okay. So at the beginning of this course, I sort of promised you that we would try to make a map of our cosmos. It turns out that along the path of doing that, we've really fixated on the physical landscape, right? It seems that as cosmology moved into the academic science, it was squarely in the domain of physics, right? But it turns out that that's a pretty recent way of looking at things. So most of our ancestors, right, if you think about how many humans came before us and gave us this classroom and gave us this everything that we have, most of those people weren't thinking about cosmology, let's say, this place, this universe. They weren't thinking about it in terms of physics. It's a very new idea. And so what I want to do is go back really far in time today and look at how some of our ancestors saw the universe, and then put that side by side with this physical story that we have, and see if we can't chart a path forward towards mapping this place a little bit better in the future. Because I think that I'm going to make the case to you that it's probably not wise that physics is the only place where we consider cosmology as an institution, as a university. It might not be the best, only place for it, right? I think that in some sense, I want you to keep this analogy in mind, that you have two eyes for a reason, right? So that you can triangulate reality, right? If you close one of your eyes and walk around, you might trip over some stuff because you don't have that depth perception. If you have two different ways of approaching the cosmos, right? One which is physical and one which is metaphysical, you might have a better chance of navigating the future. And so that's sort of the frame that I want to pursue this with. Now, I think we've done a good job of reviewing the standard cosmology, the lambda CDM, so the cold dark matter expansion, red shift, space-time expanding, the Big Bang, cold dark matter, all of this. One of the biggest arguments and one of the biggest complaints, let's say, very mainstream complaints against this cosmology is that it's completely unfalsifiable. So in other words, Karl Popper had this idea about science, that in order for a theory to be a truly scientific theory, there had to be an experiment that could be done which, if it gave a certain result, would prove the theory false. And it's not clear that that is what lambda CDM is. In other words, if you say that the universe is expanding, and that's what the redshifts are caused by, well, if we discover that certain of those stars are redshifted too much, then the Big Bang cosmologists say, oh, well, the expansion is just speeding up. But Karl Popper would say, no, I just falsified your theory that it's expanding because those data points don't fit onto your theory, right? So the thing kind of seems to like, it's kind of like a slime or something like a jello that just squishes into whatever whatever results come forward. Oh, we've discovered galaxies fully formed at the beginning of the universe. Oh, that's fine. We'll just modify the theory a little bit so that we can form them really quick all of a sudden. It's almost like an undefeatable theory, which Karl Popper would say makes it not a scientific theory at all. So that's one of the most salient criticisms in general. We've talked about the other leg, the CMB. I think we've kind of beaten that to death. Now, there's a couple of other cosmologies. So in some sense, we do, as we go back into history, which we will in just a moment, we will encounter some of these themes, right? We'll encounter the idea of this, what I like to call the cosmic egg, but the idea that the universe hatches at one point, it's born forth, right? There's also a concept that's quite common, which is this concept of eternity. And then there's the concept of cyclicity, that things the universe comes and goes and comes and goes. You see this in Eastern metaphysics for the most part. Like the Hindu, the Indian traditions in particular have this cyclic cosmology, which I think is really interesting. And I actually think that there's a little piece of all of those that is probably pointing the direction towards what's actually valid. But something really interesting happened, you know, and I was talking about this with you before class, about how somewhere around the Enlightenment movement and the printing press and all of this, the church kind of lost its grip on the state, let's say. States began to distance themselves from the church. Thinkers began to distance themselves from theology. Science really became a thing, experimentally testing ideas out. Maybe Galileo was the first of those. But for whatever reason, superstition became less and less popular in an institutional sense, right? And so, you know, that might be a good thing. You know, we can understand how things work without invoking, you know, spirits and so forth to explain them, right? Seems like a good thing on the face. But the problem is, there's a lot more happening in everyone's lives than simply moving atoms around, right? I mean, most of the things you guys are concerned with right at this moment, whether you're worrying about a final exam you have or worrying about a date that you're going to go on later tonight or whatever, those things have nothing to do with atoms crashing into each other, as far as I can tell. So there's a huge layer of concern in the life of a human being that has nothing to do with physics, right? It has nothing to do with even necessarily anything rational. I'm not sure that emotional, like how you feel about someone you love is a rational thing necessarily, right? You can't necessarily, my wife loves to do this thing too. I'll be like, I love you. She'll be like, why? I'll be like, like, it's so messed up. But, right? It's like, I don't like have a list of reasons, right? Like, we've been best friends for over a decade. I don't know, like all these reasons. Like, I guess I could come up with reasons, but like, there's a whole realm of existence that has nothing to do with rationalization. So what I think may have happened is that as people institutionally became fixated on rationality, on physics, on material explanations, that when that became the entire approach to understanding reality, let's say, that the impossibility of reality being explained by those sorts of approaches opened the back door for all sorts of spooky, weird, metaphysical, superstitious stuff to creep into those studies, right? So like, look, physics, what the heck is physics? I guess that's like a good question at this point. It's like, what is physics? It's like, if you actually ask one of these cosmological mathematical physicists, what is physics? You'll basically find that it's the study of everything to them, right? But that seems completely unreasonable to me because for me, physics can only be about the study of how bodies interact with each other, right? Just material bodies pushing or pulling on each other, which is no way to explain a love affair as far as I can tell. Certainly no way to explain, you know, how a civilization behaves itself with respect to other civilizations or all these other things that really seem to happen and matter in the universe that have nothing to do with physics, right? And so as society surrendered to the physicists the job of explaining everything to them, they sort of look to the physicists to give them metaphysical explanations, you know? And I think the physicists left these back doors open because they didn't know what to do with them. So when you see these bizarre, superstitious things creeping into physics, like time warping and space bending and black holes and, you know, the Big Bang and all of these things, I honestly think it's sort of the physicists doing their best job to bear the metaphysical burden of society that's been sort of put onto their shoulders, right? It's like they're just like some scientists who are used to calculating trajectories and stuff like that, and people are looking to them to answer huge questions like, "What are we doing in this universe? How did we get here?" They're like, "Okay, we'll try. We'll try it. We can try to answer that, right?" So I think that something interesting like that has happened in the last couple hundred years. Increasingly rational science, but you know, reality isn't an entirely rational place. So the irrationalities start to, you know, let's say, infiltrate the sciences themselves. And I think understanding how this went sideways is really important, in so much as you believe that it even went sideways. You know, if in some sense, and when I give this, I'm going to talk to you about the Sumerians here in a second. But in some sense, if you look at these cosmological myths, and I wish I had time to go through more than just the Sumerians, but you know, having studied the Mayan cosmologies, the Hindu cosmologies, the Sumerian cosmologies, the Egyptian cosmologies, the Greek cosmologies, what you really start to see is that these cosmologies, so the cosmology just means the story we tell about ourselves in relation to the universe, right? What you see is that these people are sort of explaining how things go in a civilization. How things go if people don't behave themselves, how things go if people do behave themselves, right? They often have like these quasi-apocalyptic overtones to them, like, hey, if you get a really corrupt king or whatever, it's not going to work out for your people, so avoid that. So there's all these little truths baked into it. Now, the cosmology we have that essentially, you know, physics can explain this whole universe, and that it's all tending towards this cold heat death. You know, there was a birth moment, everything's going to die. It seems to lack a lot of that really beautiful, instructive valence that these ancient cosmologies have. And so, you know, you can make up your own mind about that, but I'm not sure that that's a particularly fruitful cosmology in terms of explaining humans' place in the universe. I mean, look, let me put it another way to you. How many Hollywood movies have you seen about the future, let's say, that are about some beautiful world that we've solved all of our problems, we've, you know, got abundant energy, everybody's getting along with one another, there's no murder, no rape, right? Versus how many do you see with like explosions and the earth is on fire and, you know, there's asteroids crushing us and the sun is going out, or like a black hole is coming to, like, those are the stories that we tell in our civilization. And I think they're reflective of kind of how we feel as a culture about this place. We're like, this is kind of messed up what's going on here. People are cut off from each other. Like, I think there's a little bit of a sadistic dream that this whole place crashes and burns a little bit. That's at least what I glean from looking at the landscape. It's not like we're telling this future about how everything's going great. We're working through our problems. Everything's going to be fine, right? And as we'll see in a second, the ancients seem to have integrated both of these perspectives into a homogeneous cosmology, where they're like, look, all that Hollywood stuff about fire and brimstone, like, that's possible for sure. But there's also this other possibility, right, which has to do with this balance, really, of order and imposed order versus tyranny, right? So you have chaos, which is kind of that one end of the spectrum, which is all the fire and destruction, and then you have order at the other end. And if things get too chaotic, you know, the whole society burns down. If things get too ordered, it also burns down, because you basically end up with a tyrannical state, something like a fascist state or a totalitarian regime where you can't actually be yourself. There's no actual human expression left whatsoever, because it's so ordered that nobody can actually do anything. And so it seems to me like the ancients all of these different ancient societies understood that there's like this beautiful balance that has to be struck in a civilization between this absolute madness of freedom and this absolute strangulation of control and order. And there's some happy medium that has to be struck there. So let's look at those cosmologies a little bit. This one in particular is quite interesting. And I chose to, I'm not going to have time to go through all of the different ones, but I think this is a good example because the Sumerian cosmology is, it's our oldest record in the West. There's some serious language barriers with studying Eastern cosmology, namely that the Indus script hasn't been deciphered, and the ancient Chinese scripts are equally opaque, and it's very difficult for me, as a Western scholar, to access Chinese archaeology, to be honest with you. So I have had some good conversations with Chinese archaeologists that are working in the United States, but it's very, very difficult to piece together what's going on. So I'm picking on Sumeria because we have literal translations of their actual books, and they are the oldest books that we have in the Western tradition. And the other cool thing about the Sumerians is that, as you'll see, the story the Sumerians told about the universe is basically the same as the one that was told later by the Hebrews in their Bible, which is basically the same, although different characters as the one that the Greeks told. It's very much a Western tradition, this story that gets told. So this is essentially the world, let's say, the universe, according to the Sumerians, which is quite interesting if you check it out. First of all, there's this layer of water that surrounds everything. It's down below, it's up above. And this makes sense, right? Because anybody who's drilled a hole in the ground deep enough will find that there is water down there. So this isn't totally irrational. And then, of course, there's earth on top of that. Now, and then there's this sort of heavens above with the different actors playing out. And the stars and the suns and so forth, these are all different deities. They have different personalities that they take on, and we'll get to those in a second. So, the sea itself sort of, in the Sumerian tradition, represents chaos, right? The sea from which life arises, it gives rise to life, but it is not life itself. So in the very beginning of time in the Sumerian tradition, you have this story where these spirits of salt and fresh water combine, they mingle. So these two deities named Apsu and Tiamat. And they sort of are locked together in some sort of, it's almost like a copulation, right? This is almost like a reproductive thing in some sense. And what happens is that from this mixing of the salt water, which is, of course, the sea at the edge, right? If you go out far enough on the land to these people, you get the salty water. If you go down below, you get the fresh water. So the mixing of these two primordial liquids gives rise to people and to the gods, right? And the way that they talk about people is indistinguishable in some sense from gods. So each person is an assemblage of gods. And we've talked about this in the Greek tradition before when we did the lecture on mythology, but I think it's reasonable to assume that they saw that humans could be possessed by very similar emotions from time to time, for lack of a better word. Let's say motivational circuits, right? You fall in love, right? Is it really that different than when your roommate falls in love? No, you guys basically act the same, right? You get angry. Is it really that different than when your brother gets angry? No, it's the same thing, right? So there's these different possessions, these different emotional circuits that can take over. So as soon as the humans are born, basically, they're subject to these gods. Now, something interesting happens. The gods, or the people, however you interpret this, they actually end up killing the male of these. There's these two deities that emerge from the water, from the chaotic water. There's a female and a male. The female is Tiamat, the male is Apsu. The gods actually overwhelm the male and kill off the male. Now, this is an interesting point because in this sense, what's going on? So the male has these, in some sense, in all of these stories, the Apsu sort of represents this ordered side of reality, right? The law-giving, the one that's constructive and actually putting sort of fences around things and so forth, right? Whereas Tiamat, this is the female deity, is more of this spirit of chaos, so keeping things torn up and freed and free. I think liberation is probably a good way to think about it. So for some reason in this story, all of the gods within the people rise up and kill off the male side of things, which is interesting. So what is, in some sense you think like, what does that possibly represent? Well, like I said at the beginning, sometimes that male, in this story anyways, that male spirit of order can get pretty oppressive actually, right? So you can imagine, I don't know if you guys have probably all been on a team or been in a friendship with somebody who's always just telling everybody what to do, right? And it's like, geez, can we just do something else for a change? Or maybe you've been in a relationship like this that you had to get out of at some point. Somebody who's overly ordered can be really tyrannical, honestly. And in some sense, I think you can generalize that to a whole civilization. When a civilization gets overly ordered, right, it can become really, really oppressive. Now, there's good examples of that, right? In some sense, Nazi Germany was a great example of that. In some sense, Soviet Russia was a great example of that, where these people literally sat down and they reasoned their way through what a great utopian civilization would look like. And in the case of the Nazis, they decided that it would be a super homogeneous group of people who looked one way, had some shared ethnicity, and basically everybody else could go to hell, right? In the case of the Soviet Unions, they were like, well, the best way for a civilization to unfold is that if we figure out exactly how much resources go to each person scientifically, we calculate it, make that happen. Well, that turned out to be a different kind of hell, right? Perhaps a much worse hell. Maybe it killed 10 times as many people in the process. So this over-ordering thing, it doesn't work out. The people kill off this spirit of order. And what's interesting is that then, when this happens, Tiamat gets angry. She's the female side, the more chaotic side, and she comes and attacks all of the people. And there's this story of a flood involved in that, right? So you can think of Tiamat's, the action of Tiamat as sort of natural consequences of chaos, right? So what happened? The people essentially killed off, they realized that their order-giving structure was too tyrannical. They wiped it out, right? Which is good in some sense. But the problem is, if you wipe out your order-giving structure without having a backup plan, that's not a good situation at all, right? So she sends the flood. The flood destroys all of the people. Now, this is interesting. I think that there is some wisdom baked in here about being prepared for natural disasters. So you might think, well, an earthquake is devastating, right? If we had a 7.0 earthquake in this classroom right now, it would probably be really bad. Okay, fair enough. But it does seem to depend, the outcome of such an event does very much seem to depend on how well structured a society is to handle those kinds of things. So a good case in point is two earthquakes that happened not so long ago, two 7.0-ish earthquakes that happened. One was in Haiti, one was in LA. The Haitian earthquake killed something like 200,000 people. The LA earthquake killed something like 60 people. Okay, now, what's the difference between Haiti and LA? Well, Haiti, for a number of reasons, right? If you study the history of Haiti, it is crazy, actually. So it was basically, it was set up as a slave plantation, essentially. Originally, the slaves eventually ended up rebelling and taking over the island from their conquerors. And then, since they did that, all of the Western conquerors hated them forever and basically made sure that they would never thrive as a people ever since. So they were extremely disadvantaged throughout the entire history of the development in terms of modern civilization of that island. So if you have a hobbled economy with no real ability to respond to natural disasters, the result is when the earthquake strikes, you're kind of screwed. course, LA, one of the most rich cities that's ever existed on the planet, unbelievably wealthy California is. I mean, California could be its own country as far as economics are concerned, right? They have this earthquake. They basically have things up and running by the end of the weekend, something like that, right? So there's a story there. I think there's some wisdom baked into this story about what happens when you have the loss of this order-giving spirit, for lack of a better word. This spirit of order has been sort of banished from the kingdom. Then the natural disaster hits and everything is completely lost. Now, of course, the more elevated gods, right? This whole universe for them is populated by all these different gods, which of course represent different archetypical, let's say, intuitions or emotions. The other gods, they feel bad about this. They're like, whoa, 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 whoa. Tiamat's killing off all the people. This isn't fair. They take pity on them, right? And so they send they send a leader named Marduk, actually, to guide the people into a more harmonious existence that can sort of weather the two forces of Apsu and Tiamat. Now, Marduk's a really interesting character, and so now we start to get into the actual ceremonial history of the Sumerian people, because Marduk becomes the central deity. And in fact, in subsequent Sumerian civil, let's say, iterations like Babylon and so forth, the rulers actually take on the name of Marduk. So when you get a new ruler, it's basically just Marduk in a new incarnation, right? Now, who's this Marduk guy? Marduk's really, really interesting because Marduk possesses two superpowers. One, he has incredible vision. He's got eyes all around his head. Second of all, he can talk really well. Now, he looks like a real monster, right? But in some sense, you think about those two attributes right there. They are actually, in some sense, particularly unique to humans. And they are, in some sense, what you would really want out of a leader, too. Somebody who can see what's going on, and somebody who can take in what everybody's saying and articulate it in a way that they actually can get stuff done, right? And so Marduk seems to be a sort of totem that shows what the people expect from their leaders going forth. And it's true. If somebody wasn't being a good Marduk, they just get rid of him and put a new one in, right? Because they hold people to this standard, which is really, I think that's really fascinating in terms of what do we hold, who are our leaders today? We get a new leader every 4 years. As far as I can tell, the only thing that they're upheld to is that they can raise enough capital to get through an election cycle, right? We don't have anything like any of these supreme expectations for our leaders, like they should be beholden to any particular let's say, elevated ideals or archetypical ideals of what somebody who guides civilization should look like. I mean, there's some argument that we have a little bit of a mythology going in this country, right, regarding our founding fathers, right, maybe? And if that is true, then I think that the coolest part of that myth goes back to the fact that our founding fathers, let's say, there's a very poignant quote from Thomas Jefferson where he says, the best thing I ever did as president was to decide not to become president again, which is really interesting. So by deciding not to essentially take on generational rulership, to become a king, essentially, that they were doing something quite radical, which we've preserved up to this moment, which is interesting. Now, okay, so we see some version of this story playing out. It plays out in the Hebrew Bible. It plays out, I think that's probably the most obvious place to look. It also plays out for the Egyptians. So the Egyptians' central text is called the Book of the Dead. They have this infinite expanse of darkness and directionless waters, which they call Nun. But Nun is also divided up into pairs of male and female deities, very similarly to the Sumerians. Then essentially, some dramas unfold, and this supreme deity named Re which is represented by the sun, by the way, is sent down to rule over Earth, very much like Marduk. And humans are actually created from the eye of Re, this vision, right? So you see this aspect of vision and awareness coming into play with this central deity, this central ruler. I think it's really important too to think, even the sun itself, it's like this idea that clarity is associated with light is as old as time, right? This idea that vision, right? It's impossible to think about things like being smart or being wise without bringing in metaphors regarding light, right? You're enlightened, right? Or that was a bright idea, or brilliant idea. These are all visual analogies. There's no way to think about intelligence and God, I can't even say anything. Foresight, vision, like all of these things, right? We say, oh, this person really has vision. Does that mean they have 20/20 no, it just means they have prescience about what's happening, right? So all of these visual analogies continue to make their way into all of these cosmologies about basically celebrating those that can see, those deities that actually can see what's going on, and essentially styling their rulers after these people. This is kind of the point, just to tie this back into the bigger narrative. These are the pieces of cosmology that don't make it into a cosmology that's based on physics alone, right? And I'm not sure that that's a good thing necessarily. Now, I'm not saying physics should be doing this kind of cosmology. I'm saying that perhaps cosmology should be a bigger science than just physics alone. That's what I'm saying. Because we could use a cosmology as a people. I don't think we can get by without one, actually, in the long run. This idea that heaven and earth were joined is also very common amongst all these cosmologies. At some point, right, the waters separate, right, or oftentimes the heavens separate from the earth. I don't think that what these people meant by heaven was like some, Disneyland in the sky. And what they meant by earth was like the planet. I don't think they had that same conception. I think what they mean generally by heaven is the ideal, really, like what this place could be like, the best version of the world, something like that. Whereas the earth is kind of the failed experiment at all times of how things are going. There's a chapter in the Quran to support that. Let's see, chapter 21, verse 30. Have those who disbelieve not considered that the heavens and earth were once a joined entity and we separated them, right? So humans are always at odds with what the ideal version of themselves could be. I think this plays out, and I think why these cosmologies are so powerful and so long-lasting is because not only are they true for the civilization, for the people in general, but they're true for yourself too. They're true on a very personal, individual level. It's like we're always kind of fighting, we're always running up against the wall of not doing the best version of ourselves, no matter how far we get. And there's a progress to it, right? Hopefully you get better at that as you age. You learn lessons about how to behave yourself. But you're always sort of running up against this ideal of the best version of yourself. And I think civilizations are no different. All right, so this world egg, cosmic egg thing also pops up all over the place too. It seems to actually, it's fair to trace that back to Proto-Indo-European cultures. Although you see it in West Africa, Japan, and honestly you see it in Lemaitre's Big Bang, right? This idea that the world hatches. Usually in these world egg stories, again, you see the mixing of two complementary pieces, which is interesting because there's something very biological and vulgar about that as well. But I think people were very well aware that that's where life comes from, is in some sense the mixing of different substances as well. So you see this motif pop up over and over and over again. You see it in Zoroastrianism, which is an Iranian tradition. This is, creation of the sky, enclosed it in a world like the shell of an egg. Water filled the lower half of the egg. I think also the idea of an egg is symbolic for people because you got to think, and this was more apparent last semester when I believe it was last semester. But look, if you're just a person and you've never inherited any of this idea about the solar system and so forth, you look up at the sky at night, you see the stars moving across you, It looks like a shell moving over top of your head, right? It's not an idiotic idea at all. It's actually, from a relativistic standpoint, it's a perfectly valid perspective that the Earth is rotating around your head. And in fact, like as far as I can tell, particularly given the equivalence principle of inertia and gravity, like the Earth spinning is no different than the whole universe spinning around the Earth. There's no way to separate out those two things from being true. So these people's idea that we're all sitting inside of this egg in which all of this is playing out, and then that egg had to have grown from some point at some point, it's not an irrational idea. So we can trace this idea too all the way back to these Sanskrit scriptures as well. There's a cosmic egg in the Hindu cosmology, at least at the base of it. Of course, the Hindus add this other idea to it that the egg hatches and then another egg is born after trillions and trillions of years. So they have kind of a Big Bang cosmology that's cyclic. It's like there's new bangs all the time. I guess what I'm trying to impress upon you with these sorts of things is that the basis for our Western cosmology, this Big Bang thing, right? It's not a new idea. It's been around for a very, very long time. And of course, it made its way into the Judeo-Christian tradition, Islamic tradition, and then eventually found its way into the hands of this priest named Lemaitre who gave it to physics to explain the Hubble redshift business. So, you know, the Mayans also had a really interesting cyclic cosmology. They believed that there would be this birth, and there was, of course, a twinning of spirits in the beginning in creation, but that it happens over and over again, that there's a cycle to the creation and destruction of the world. And in some sense, I think that also plays out in terms of when we look at the civilization as a static entity, right? We look at the Sumerian idea of like the battle between chaos and order. It's like, yeah, sometimes things do go too far in the ordered direction, or things do go too far in the chaotic direction. But on balance, things sweep back. There's almost like a pendulum swinging at all times between each one of those poles in society. You know, you see these moments where the society gets too conservative and everybody freaks out. And this was kind of what happened in the 1950s, followed by the 1960s. Becomes ultra-liberal. Then you have all these hippies everywhere. And then everybody starts to hate the hippies, and then it swings back, and you have the 1980s where everybody's just making all this bank in the stock markets and everything. It's like, this is kind of how it goes, right? This cyclic version of reality, there's some truth to it. And these people seem to have encoded it in their mythology. The Mayans seem to have gotten it. The Indians seem to have gotten it. The Sumerians in their own ways seem to have gotten it. The only people that don't seem to get it are us today, who put our entire cosmology in the physical realm and try to explain things based on atoms crashing into each other. I don't know that that's able to even bring these kind of ideas into it, nor should it, right? Those are not physical ideas. So, you know, indigenous people are also really, really interesting. So I had a fascinating conversation with this scholar of religious studies she's published a couple of books so far. She's done some really good podcasts. We had a podcast with her. Her name's Diana Pasulka, and she's working on a book right now. I don't think it's out, but she was going around talking to indigenous people throughout North America about their cosmological stories, particularly as it related to the modern day obsession with UFOs and so forth, which is really interesting. So, you know, people have been seeing all sorts of weird stuff in the sky forever. There's like stuff going back thousands of years, people talking about stuff in the sky. Now, people 2,000 years ago, when they see something in the sky, they interpret it in the cultural context of the world they live in. So the things in the sky are gods or angels or demons or something, right? Today, they're stealth bombers, basically, from another world or something, right? Like, we see these things in the sky, and we're like, oh, well, that's obviously a high-tech, spaceship or something, because that's where our cosmology is today, right? That's the way we look at the world. We look at the future as being full of, stealth bombers and spaceships that go to other stars and stuff, right? So, of course, we interpret it that way. But what was interesting is she went to the Native Americans. She starts asking them about this. Well, it's interesting because in several of these Native American traditions, they have this story, this eschatology, right? So this kind of end of the world story of how these star people come to Earth. she was interested in this because she thought, is that something like UFOs or whatever? And the indigenous people said to her, no, that's you guys. And so she said, well, are you guys worried about aliens coming or anything? And she's like, this, I think she held up the cell phone or something, and she was like, that's what this is, right? She's like, this artificial intelligence, these kids being like locked into their screens and stuff all over the reservation, that's what's happening right now. This is the end of the world for them, which is completely reasonable since their civilization's been completely decimated, right? Most of them wiped out before the colonists even had a chance to get in fights with them. I think by some estimates, like 95% of the population of North America was wiped out before people even started coming off the ships. Essentially, they were infected by smallpox or something like that. So the end of the world already happened for these people is what the point was. And so the story is actually already played out. The aliens are the colonists. They are not some people from other solar systems. So the way that we interpret things really has a lot to do with our own experiences at any given point in time. And I think the UFO story is a really interesting level to examine that at, because the way that each culture interprets it says a lot more about what they expect to be their future than it does about anything else. Same way that our Hollywood movies say a lot more about how we feel about our civilization than they do about the reality of the future, right? So I'm gonna have to wind this down. I was gonna walk you guys through this story of, I think we've done a pretty good job of building out the story of how we got to the modern cosmology with the Big Bang and everything. It's worth pointing out that, reiterating that, of course, Einstein was a big fan of this static universe and of this eternal universe. He was only sort of persuaded as a result of his cosmological constant, which apparently was one of the biggest nightmares of his life, which was this force he had to essentially insert into his equations to keep gravity from crunching everything. So when Hubble came along and said, hey, don't worry about it, there was a Big Bang, the universe is expanding because it was an explosion, then your cosmological constant can fit into this story. And he said, he kind of surrendered to it, said, okay. There was a competing cosmology at the time, all the way up until the 1990s, although it was kind of dying by then, but let's say pretty well supported up into the 80s, primarily championed by this guy named Fred Hoyle. There was a bunch of influential papers that started coming out in the late 1940s, Herman Bondi, Thomas Gould, Fred Hoyle, and they basically proposed this idea like, hey, all right, you have this redshift, things appear to be moving apart from each other, fine, let's just accept that that's actually a Doppler, there's some sort of motion. What we propose is happening actually is that these active galactic nuclei, which we talked about last week, what's happening is they're shooting out all of this new matter in every direction, which is driving the galaxies apart from one another. So new galaxies get formed and they sort of push out. And so in reality, it does seem like the galaxies are all moving away from one another, but it's because there's actually new creation of material happening. As these jets spray out all this new stuff, it condenses, forms new galaxies, they spray stuff and push everybody away. Okay, so that was a pretty seriously entertained idea. Now, the sad part is that, and I really love Fred Hoyle. I've read a few of his books. He's just an incredible writer. I highly recommend him if you're interested in this stuff. He could not explain the CMB for the life of him, unfortunately. So in the 1960s, 70s, they actually started sending more and more of these probes. I walked you through a few of them last time. He couldn't do it. He didn't know what it was. And he kind of hung up his hat at the end of his career, and he was just like, I don't know. I wouldn't say that he completely surrendered to the Big Bang, but he just couldn't deal with that pillar, right? Big Bang's walking on two stilts. One of them's the redshifts. Hoyle could deal with the redshifts, but he didn't know how to deal with the CMB. So that's a bit of a tragic story. All right. I think we've covered a lot of the main themes here, We don't always see what's happening in the world directly as it's happening, but it's important that we see what's meaningful, right? So this ability to focus our attention on what matters, it seems to be at the heart of all of these cosmologies. They put these deities in place to guide humanity who have vision and have the ability to see from above, right? Now, in our cosmology, and this story that I told across this course, there's things that we can't see, right? And what's interesting, those things that we can't see the source of gravitation at the center of an orbital system, right? And we can't see what's causing the galaxy to rotate the way that it does, or we can't see what's causing this expansion to happen. And so one thing that we do now, it seems, is we stick in these placeholders like dark matter, black holes, dark energy, right? And we act as if those are seen entities now all of a sudden, right? Those can explain it. So what we can't see is now the explanation. I think this is something I want you to really walk away from this course with, that we have blind spots, and we can't treat those blind spots as if they're actually part of our real vision, or we'll have no chance of actually moving through that. So look, there's two different maps possible, right? There's a map of the physical reality, and there's a map of how to behave in this world. Both are integral parts of our existence. Only one of them can be addressed by physics. The other one needs something more like myth, more like art, dance. Sports are a fantastic version of this, actually, right? Where you have teams, right? And the people have to work together and come up with strategies and so forth. There's a lot of cosmological dramas that we play out in this civilization that have nothing to do with physics, right? And it's really important, I think, moving forward that we integrate those and that we don't expect the physicists to give us answers to things that they were never, ever equipped to give us. So I hope you guys have enjoyed this course. I hope that you've learned something. I hope you've at least gotten something to think about. Feel free to email me at any point in your lives down the road, particularly when those headlines snap about the material basis of the sun. And if anybody has any questions, I'll hang out for a while after class. And yeah, it's been really fun having you guys. And good luck with all your finals. And do well.